So I'm Steve French. I'm a principal software engineer at Microsoft. I work in a completely different group than Genghis and his team, but I feel like I'm working in a science fiction novel with the largest server in the world, apparently. What I work on, though, is Linux. So my focus has been on improving Linux access to the world, right? Making it easy to access the smallest embedded devices, like some of those things from the visuality in the back, to the largest servers, Windows, Macs, everything else. And just a reminder, this is my opinions, not necessarily those of Microsoft's. Now, I've been maintaining the Linux client for a long time, but I also have to remember that most of the work comes from a very large team of people, many of which are actually here, or perhaps listening remotely. What I want to talk about today, though, I want to start with the amazing amount of FS activity. And I was reminded of this recently. I don't know, have you guys ever been to an in-person meeting? Like an in-person conference? I don't know. We used to do these in-person conferences. But a few months ago, the first in-person conference was the Linux File System Developer Summit. And so I wanted to, this was amazing because it reminded me of the insane amount of work and churn and improvements that are going on every month in Linux. And LWN, the Linux Weekly News, has good summaries. There's lots of good things on mailing lists, but LWN had pretty good coverage of this if you want to catch up on some of the storage topics that are involved, and a lot of storage topics. Unfortunately, although we do have some of the key storage people, I think you'll recognize some of those faces from the hallways. Many of them are at the Linux Maintainer Summit right now, which unfortunately overlaps this year, so I had to make a hard choice. So what are we talking about in Linux? Variable size pages, folios. We're also talking about the way forward for async I/O. I think Volker touched on IOU ring, right? Right? IOU ring is the way. Thankfully, Jeremy will be very glad about this. AIO is dead. Use IOU ring. But these changes have impacts that are subtle on file systems like mine. Also, the offline cache, unlike in some other operating systems, the offline cache is sort of separate from individual file systems and shared across multiple file systems. So the local offline cache mechanism. Linux has a problem because it has to sometimes obey POSIX semantics, but we have this need for additional fields. So statx is the extended stat, and there's a similar thing for fsinfo. How do we get these additional fields back to users that are needed for workloads? How do we tell, for example, that a file is offline in the cloud? A lot of work going on with Christian Bronner and a number of people on ID mapping in containers, how to do ID map mounts. There's just a patch set for the kernel server for that I just saw a couple days ago. Also, there is a discussion, I think you probably saw Chuck Lever here at the conference. Chuck gave a presentation on TLS in the kernel. There is parts of TLS in kernel. We prefer Quick, obviously, but Quick does depend on little pieces of that. And there is work ongoing to discuss how to get Quick into the kernel, because right now it's only user space implementations. And then, of course, we have this interesting problem. If I try to access a Windows server at home, it's pretty predictable bandwidth, even if it's over Wi-Fi. If I try to access servers in the cloud, Azure could be in Dublin, could be a premium share, it could be a low-quality share. The performance difference can be 2 orders or 3 orders of magnitude difference, storage turnaround time. So we have to deal with crazy differences in latencies. So this world where we're dealing with NVMe and RDMA, smbdirect, to the slow, cheap stuff is insane. Okay, 5,608 change sets. That was as of a week ago, so it's more now. But that's over the past year since the 5.14 kernel. This is one of the most watched parts of the kernel. The kernel is 30 or 40 million lines of code, but this 6.7 of it is watched all the time. These bots, and I'm getting crazy patches from people I've never heard of because file systems are watched so carefully. Now, 1.06 million lines of code seems like a lot of code until you talk to Volker. 3.8 million lines of code is what he deals with. So I can't complain too badly. Okay, a year ago we had the opossums on parade. Linux likes crazy names. Now it's herder, I'm a ninja sloth. I have no idea why they picked that. If any of you guys know, it would make a good story, I guess. But I think I prefer it to the sloth, but that's where we are now. Now, what about file systems? How active are things? Very interesting thing happened over the last year. So the Linux file system layer usually gets double that number of changes. Dave Howells and Alviro and others do changes that affect new syscalls. There actually weren't any new syscalls added in the last 12 months. There were 4 or 5 added the previous year for file systems. And there are fewer changes to the file system mapping layer, but still file system activity went up. But the file system activity tends to be dominated by maybe 5 file systems, 6 file systems. You got 50 plus file systems, but most of them get very little attention. What gets attention? Well, BTRFS, XFS, a little bit of ext4, and then SMB and NFS. And now the NFS server, kernel server. And also we've introduced there's a new NTFS driver that got, because it was recently introduced, made the top 10 list this year. But if you look at this, these top few, BTRFS, XFS, ext4, SMB, NFS, way like 10 times more activity than most file systems. So Linux isn't quite as bad as you think. You focus on a few file systems, it's easier to think about. CIFS activity was strong this year, 260 change sets, but it's way smaller than Samba. So the 60,000 lines of code we focus on is something you can wrap your head around. And we did 22K diff this year. That's pretty substantial. I think it's like double what NFS was. Now, about 10 months ago, the kernel server was introduced into the 5.15 kernel. It's 27,000 lines of code, about 1/10 the size of the equivalent Samba piece. It doesn't do SMB1. It's much narrower in scope. It's not for all use cases. And it had 239 change sets, which put it well ahead of, let's say, NFS, for example, or most of the file systems in how much activity. But comparison matters here. Samba is orders of magnitude more active because it covers a much broader set of things. Now, we have in-person Plugfest. This is not from this Plugfest, but I should have included a picture of you fixing bugs or something. But I'm so glad about this because the amount of, well, other than the fact that we get no sleep, staying up till 2 in the morning fixing bugs is, I don't know. But it is very exciting to be back in person at these Plugfests. And over the years, we've typically had 3 or 4 a year in person. They help a lot. Okay, so let's talk about some of the recent features. So I think you talked about signing negotiation, didn't you, in your talk?
We did not.
You did not. Okay. I know Ned talked about it in Ned's talk. So one of the things that's very obvious is that signing benefits from hardware offload. And CMAC versus GMAC signing is a big difference. One of the things that we find very odd is that encrypting is much faster than signing. So there's no point in using a default, changing a server to be default to turn on signing because it just slows things down. You'd be better off like Azure does. Azure requires encryption by default. If you just required signing, it would actually slow things down. So one of the interesting things is trying to fix that by supporting AES GMAC. You can see that here. Now, there's a set of patches from Enzo. Metz and Enzo were working on trying to improve this. And so we were testing these this week. So what we're seeing so far, and we've got some work to do, is about 20% faster for the GCM GMAC signing. And that should be more like 4 times faster. So we've still got some work to do to figure out why it's not enormously faster. But the exciting thing about it is signing is faster. Those patches are making progress. And that gives an alternative for those who don't want to encrypt their share. Encryption takes advantage of hardware offload. So it significantly improves performance for some workloads. Now let's talk about it exactly. So I took laptop in there, just wrote a large file. Signing is getting 280 meg per second. Encryption, 1.1 gigabytes per second because it's using a faster algorithm. It's using hardware offload for the GCM. With the signing improvements, I was saying about 10% or so better. Now, unencrypted, I'm saying about 1.6. So, unencrypted is better, but what we're trying to do is get the signing performance to better than that. So we get, I don't know, 75, 80% of the performance that you would if you weren't signing or encrypting at all. And so we've got a little bit of work to do, but it is very exciting to realize that the default option, like say you're mounting to Azure, isn't that much slower than not encrypted or signed at all. Okay, so the next thing I find fascinating is metadata. So any of you guys remember SMB1? It had a few path-based operations that gave Jeremy heart attacks. Now, SMB2 and 3 have far fewer path-based operations, but there still are opens, a lot of them. And in general, for some server types, opens kill performance, especially in some clustering configuration. So how do you reduce metadata operations? So one of our goals in life is to use the fewest number of metadata operations. And one of the ways to do that is to leverage handle leases and directory leases. So we did some work on handle leases. We still are making improvements there, but handle leases have been in for a while. We talked about that a little bit at the last time. But directory leases, being able to defer directory close and avoid having to reopen directories multiple times, can make huge differences. And it's especially important because Linux is a terrible chatty file system model. I think Windows guys are used to opening a file. And opening a file means passing a path name down the stack. In Linux, that means passing the path name down, cutting it into each path component, making 2 operation queries, revalidate, and all this against each component in the path. So opening /tom/palo/jra/volker, you know how many operations that is on the wire? That's a lot of opens as you go directory by directory. So directory caching matters. So Ronnie Sahlberg at Red Hat has some test patches that we were testing. As a matter of fact, literally, Paolo and I were looking at it a few minutes before this, testing some extra things. We're expecting that and the signing patch to be in the next merge window that'll open in 3 or 4 weeks. And to give you an example, here's a simple example with the patch set that we have today. It's out on the list, and you can try it yourself if you'd like. I did an ls of a directory and then a stat of one of the files in the directory. That would normally have additional opens. So as you can see here, we did an ls of temp, and you can see the find request for temp. And then 5 seconds later, you can see the close of temp, 5 seconds in. And we also have one extra response that Paolo and I were looking at removing. So this compounded request here is somewhat redundant. But once again, because of the chatty VFS in Linux, we have to deal with that. But the improvement we're seeing here is we would have normally seen an extra create, get info, close for this populate root file. So this thing here, the Wireshark trace, we've avoided an expensive create, query, close because we were able to use the cached information for 5 seconds from the previous LS. This isn't as good as Windows does, and probably not as good as the Mac does yet, but what it's doing right now is significantly cutting down metadata operations, and we're trying to improve that. Now, let's talk about deferred close. So Bharath, and actually Rohith, had done some nice work here. The pattern that it fixed was the stupid apps that do open, read, close, open, read, close, open, read, close. You've probably seen 1 or 2 of those, right? The problem is that in Linux, close flushes the cache and all that, right? So you've lost, anyway, so the problem is open, read, close, open, read, close, open, read, close. You'd end up doing a lot of extra opens as well. And one of the nice things about this is that it did default to 1 second, now 5 seconds. Now open, read, close, open, read, close, open, read, close is basically open, read, 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 and 5 seconds later close. So you've saved a huge number of metadata operations with this. Now, this has to be extended to cover additional scenarios. So there are scenarios, especially I think you saw from this slide, where we should have reused this handle. Now that's a directory handle, but we have the same problem with files, that sometimes we're doing query infos revalidate where we're not reusing handles in a couple paths that we can. So that'll significantly reduce metadata operations. Now, what does this mean? It'll mean way less load on the server, way less CPU on the server, less ACL in Samba and Windows. It's very expensive to have to go through all the ACL checks. Obviously, being able to use a cached handle significantly helps with that. Okay, now, Ned's not here, but I wish he was, because he'd probably have a picture of, I don't know, what dog would he, what would he have a picture of? I mean, something threatening with a dog and SMB1. We want to get rid of SMB1, but we live in a world that's even worse than the Windows world, probably, in regard to this. We were dealing with a patch. Matter of fact, we just got from Ronnie a Windows 98 VM, so we could test a patch to make sure we regressed, apparently, some scenario to Windows 98. Unfortunately, in Linux, people actually care about these 100-year-old systems, but we're gradually moving that code out. So just as we talked about, as Ned talked about, we could have a separate module in the long run. And by default, you can turn off the SMB1 support, so it's not even included. It saves about 10% of the memory footprint of your module if you don't compile in the SMB1 code, and we can gradually get that to probably 20%. But we're gradually moving this code out into ifdefs, so it's easier and easier to isolate the SMB1 code. We really don't want people to use SMB1. And the last piece of getting rid of SMB1 is the POSIX extensions that we were touching on earlier. So getting these POSIX extensions stable in Samba and stable in other servers is very important, so we can never have a reason to go to SMB1. Now, we have removed NTLM v1, and that generated enough controversy, but NTLM v2 with SMB1 is still something we do not want to be doing. And this is a step in the right direction. Like I said, we've got about 10% of the code you can ifdef out now. Okay, let's talk about multi-channel. One of the beauties of SMB is its ability to dynamically query and change the network interfaces to deal with people like Chelsea-O out there who have, 400 gig adapters? Imagine if you put in imagine if you had a slow adapter and then you just popped in that Chelsea-O card, right? Wouldn't you want to auto-detect it in a few minutes and start using it? Well, Windows does. So one of the things we're now doing, thanks to Shyam, is we're requerying the network interfaces similar to Windows, and also on Reconnect, we're doing a better job of requerying the interfaces, and if the interfaces have changed on Reconnect, we're dynamically using that. Now, multi-channel is not turned on by default in Linux, so you have to mount with a max channels, tell us how many channels you want us to try. But we will soon be enabling that by default when we have more confidence about how to more sanely detect how many channels to use. But the big picture here is that if you inserted a new network adapter on the server, or if your network adapters change, we will see that, like Windows will, and requery those periodically and adjust the number of channels. And there are also a number of reconnect improvements that were made. Okay, so one of the things that Tom Talpi and Metz have been doing, and it was touched on in the earlier presentation, was rethinking, looking through how smbdirect is implemented. And one of the things to remember, and I think it's a very important thing that I heard 3 or 4 different people mention, is that smbdirect is not really SMB. smbdirect is the RDMA thin transport layer. Is that a fair way to put it, Tom?
Framing protocol.
Okay. So a framing protocol on RDMA, and it makes it feel more like a TCP socket to me. Is that fair? Sort of, okay. What I want to think about, though, what I want to kind of emphasize is that there's places that really don't have a lot of SMB dependency that need this. And currently, the users of smbdirect in Linux, unlike in Windows, are pretty much the kernel server and the kernel client, but they have their separate implementations. So one of the goals is to fix these problems with the client implementation, but then gradually move, as was talked about earlier, to having a sort of a transport driver, an smbdirect driver, that modules share and also could be used from user space and other kernel applications in the future. But in the short term, we have a more urgent problem of, take an example. We try to maniacally run tests. One thing learned from Samba is that you have to run tests on every check-in if you can. So we created this build bot, 4 years ago roughly, and have gradually been improving it, adding the standard file system tests for Linux, and the Git regression tests and various file system regression tests and SMB specific tests. And these tests are run before we send anything up to Linus. The problem with that is it is 0 on RDMA, 0. And one of the reasons is soft iWarp wasn't working. So his patches fix the soft iWarp example so we can at least run emulated RDMA, even if the test environment doesn't have real RDMA. It fixes RDMA responder resources. And
Not yet, that's the to-do.
okay, the to-do here. The not wait for completion, so we don't want to stall the pipeline. Make compounds more efficient. The other thing that's kind of odd is we're using the wrong size for many things. That magic 1364 size should be used more commonly. And I think that you can see here that that helps with the sort of KMM cache packing here. We also need to fix some reconnect when the connection's being held when something's shutting down. And then finally, we've got to kind of merge implementations when the server and the client have different stuff so it becomes less confusing. So these are sort of early observations, but then longer term we have, how do we make SMBdirect for the world? In the Windows world, SMBdirect is used all kinds of cluster implementations and backends and all kinds of stuff. And it's very exciting in what it's used in Windows. This abstraction layer makes it more usable. So the longer term plan is to take the code out of sifs.ko, ksmbd, create the SMBdirect driver. And this SMBdirect driver will provide this PF SMBdirect socket abstraction. So that framing on top of RDMA to allow RDMA to be easier to use for Linux, whether or not you're talking about SMB, but it'll also allow the kernel client and kernel server to share code, and it'll shrink the amount of code we have to maintain, which is a very good thing. Linux tends to get obsessive about keeping the code as small as possible. And finally, it will also allow user space applications, Samba perhaps, but certainly client libraries, they want to use this, to be able to access RDMA with good performance. Aurelian's earlier experiments trying to do SMBdirect all in user space had relatively poor performance. So this should be much faster. And it will also allow us this idea of an echo server client SMBdirect test. So it has nothing to do with SMB, but just to make sure that SMBdirect is working, these tests are being developed to improve our ability to regression test SMBdirect without requiring any SMB server or client. And thanks to Tom and to Metz for their work on this, but what I want to strongly encourage people, since there's no one person who knows everything about RDMA, there's no one person who knows everything about SMBdirect, is really want feedback, review, testing, comments on this. And there's been a lot of great discussion this week, but there's also pieces of this that are beyond one person's knowledge. And looking forward, I find this unbelievably exciting, and I hope you guys do as well. Okay, we had a talk yesterday about the POSIX extensions, so you can go see the slides on the SMB3.1.1 POSIX extensions. This is the last step toward killing SMB1. There are... And NFS, well, whatever. I got to be nice here. Chuck Lever's here, But in any case, what I want to be, maybe here's a way to think about it. We have 1 or 2 iPads in the world, and maybe 3 or 4 iPhones in the world. And even, I see a Mac there. They use SMB, right? We have Linux. We have Samba servers in small devices. We have embedded devices, large. We have to think about, SMB3.1.1 is this common language for accessing files. But to do that, there are workloads that require extensions. Not a ton, but there are workloads that require extensions. And there are workloads that would perform better if we had these extensions. Now, the SMB3.1.1 extensions were sort of developed, Jeremy and I and others, about 5 years ago. But 5 years ago, there wasn't COVID, there were test events, and we were making pretty good progress. But also, the Symlink, I guess, Jeremy, you haven't given your talk yet, right? Okay. If you wanted a really exciting topic to give you a heart attack, listen to Jeremy's talk on Symlinks. And Volkers, okay. But what I want to emphasize is that we had a kind of a 2-year break here on this, and now we're crazy active testing this. So there was a lot of progress on the POSIX extensions. The clients had them for a while, but there's minor things to deal with. Now Samba server is making good progress. So we've been testing, you got 3 different servers there, 2 different clients there, or actually 3 if you count a test client. Setting up the POSIX extensions on ksmbd doesn't require anything on Samba, it just requires SMB3 Unix extensions equals yes. So it's an easy thing on the server to set up. Mounting from the Linux client is pretty simple. You see POSIX, that's all that's required. You put POSIX on the mount command, we will ask the server if it supports POSIX on negotiate. And as you can see here, it worked, because you can see 3.1.1 was negotiated and POSIX. So it's not turned on by default. You have to specify it on mount, but it's trivial to test. Now, why might you care? Here's an example. We did an ls-l. Okay? Notice we have the mode bits and the owner information. We tell who owns the file, that's a good thing, and we tell the exact mode bits without having to do an expensive ACL query, right? Doing ACL queries across the network and parsing them is a mess. So this is very cheap. You can see how small this frame is, and basically, it's not that hard for the server. It has to return a permissions field, and the SIDs are, the ownership is returned as a SID to make it more compatible in the broader scheme of Windows and Linux and Macs. Now we also had minor things to deal with, like query fsinfo. The 2 fields in yellow are not available without POSIX extension. These are the inodes free and inodes available. Not a huge thing, but adding an info level was easy, and it's something that was similar to what was done in the SMB1 extensions. We've also improved performance. So here's an example before this week. Okay, see this example where we did an open and then a query Linux info, query POSIX info, and then close. Now look, compounded. It's faster. So we found, obviously we'll find others, but we also want to make sure that performance doesn't get worse with the POSIX extensions, because we were already compounding to Windows and to Macs. But with the POSIX extensions, we want to make sure we don't miss places where we're doing extra round trips. So these are minor things that we're finding, but they help performance. Okay, let's talk about kernel server. Kernel server was merged in 5.15, and here's a kind of description of the architecture. And I think, as Volker mentioned, one of the things that has to be done pretty importantly is, you see this upcall here for DCRPC? The kernel server needs to be small, and it is small right now. But we don't want to implement DCRPC code and things like that in the kernel, right? Things that are not super performance sensitive need to be in Samba code. So one of the longer term goals is figuring out how to better integrate Samba services with the higher performance stuff in the kernel, because there are some workloads where this does seem to benefit. Recently, they added RSS support to ksmbd. So these slides are from Namjay, by the way. 3 times faster for read, 4 times faster for write is not a bad thing. RSS can help. And here's a comparison of multi-channel with RSS. So kind of fun stuff to look at. And one of his focus items has been on smbdirect and how to improve performance, and also improving the compatibility with various types of NICs. So working with Chelsea.io and working with Soft iRope and Soft Rocky and Mellanox and the different adapter types and emulation types to make sure they work with ksmbd, and also to be able to better auto-detect the RDMA NICs. One of the things I love about SMB is, like, if you have a Windows system, putting in an RDMA card and getting smbdirect to work, getting an SMB mount to use it is not hard at all. But otherwise it can be hell. So I kind of like that he's improving the ability to auto-detect and handle this in ways that allow even a normal human to use RDMA. And being able to handle these larger frames is great, and the 8 megabyte RDMA read-write size helps performance in a lot of workloads as well. So it's kind of cool, these changes for performance. Now here are some details on his performance benchmark, the server and client that were used for the benchmarks here. I don't want to go into a lot of detail on this, but after the talk, if you want to look at this or follow up with Namjay, some of this is kind of interesting. Okay, so comparison between single and multi-descriptor. You can see the significant benefit in orange versus blue of multi-descriptor. doing this frame test that was described on the previous slide. And you can also see the RDMA write performance as you go from 8 to 16 meg write size using frame test. So that's kind of an interesting thing. And the read performance increasing as you go from 8 to 16 meg for the read size. And once again, these numbers will probably improve even more as some of Metz's suggestions and Tom's suggestions and others are included in their code. And as some of this code is moved into common layers, there'll be even more opportunity to optimize it. The kernel server added support early on for AES 256 encryption. Many people talk about this as kind of military grade encryption. It may not be necessary for any workloads, but people want the strongest encryption, and so when you want the strongest encryption, you can get it. You can get it with the kernel client, you can get it with the kernel server, you can get it with Samba now, right? So there's no excuse from a security perspective. You have the strongest encryption available not to be using SMB. Windows supports it, Samba, ksmbd, Linux client. And as you can see, the acceleration you get from GCM is fascinating because you can get this incredibly strong encryption with good performance because it's offloaded to the hardware, a lot of the CPU cost. Okay, so early on with ksmbd, there were many security problems found in the first few months. And those, there was a wiki created, many of those were addressed. Obviously, Namjae and others would be very excited to have additional changes, things you find here. Issues related to RDMA and multichannel were improved recently. This getting soft IWarp working. They're getting a lot of information on the VFS. Alviro sent some patches recently. I just saw a few days ago those patches for ID mapping in containers from Christian Bronner. There's a lot of testing that's going on. Obviously, Namjae on his side is running a very large set of regression tests, including XFS tests, and then I'm running sort of independently, to make sure I'm not biased here, I'm running independently a large set of XFS tests as well before I send any pull requests to Linus for his changes. I'm a little bit involved in it. I review these patches, but I largely focus on the client and just make sure that he's doing his homework and the rest of the team working on the kernel server is doing their homework. But I am trying to make sure that we do a lot of testing. And I'm very selfish here. I work on the client, but I absolutely love that it takes me 5 minutes to tweak some little field and emulate a customer bug by putting something dumb in ksmbd to try to simulate a problem. I find it, like literally every week, I'm using it to test something. And I just find it so easy to find stuff in 20K lines of code, make a little small change, and simulate something. So this has been good for me, but I think it's also going to be useful when we have better statistics that we can show. Samba has pretty good statistics. Azure has great statistics. Windows has pretty good statistics, but trying to get things like multi-channel latency information and really accurate information on by-channel counts and latencies is kind of tricky. So I'm intrigued about that going forward and also this durable handle features, and very much interested in their progress on directory leases. He's also working on Notify. If you're interested in contributing, there's lots of features to work on. There are multiple developers helping Namjae, and take a look at the Linux CIFS mailing list, and there's also some wikis. Okay, on the client side, we've had a lot of changes. Just to give you an idea, when we're thinking about if we were in person last time, we would be talking about the changes that we're just about to go in for improving reconnect, these multi-channel improvements that went in late last year. We've had a lot of recent discussion about TCP no delay. So the Nagel algorithm we can hurt performance in SMB in many cases because we want to immediately send a request when we fully filled the buffer. So we cork and uncork the socket in the kernel. But TCP no delay may provide benefits, and that's an option now on Mount. And we've also been discussing quick ACK and whether quick ACK provides, which is the reverse, right? The TCP layer immediately sends an ACK back to the server, whether that provides benefits. So we've been testing those, but we have the Mount parms now to allow enabling TCP no delay to see if in your environment that helps. The corking and uncorking we thought originally for years was all that was needed, but it does appear like we have some workloads where that would help. So it's an interesting performance thing to do. And also on this performance improvements using compounding, there are infinite places you could compound better. So forever, we're going to be finding places where we should be combining requests and sending them at the same time. So just when you're looking at network traces, let us know if you see places like the example we showed you earlier where we should have been compounding something we weren't. Now, there's a guy named Paolo here. You need to thank him, because without Paolo, we would have a zillion reconnect bugs and DFS bugs. He's been fixing some really cool stuff with DFS and ACLs. But I tell you what, there are so many things. This world we live in is such a big protocol space. The deferred close we talked about here. Let's see. The caching the root directory thing is improved, but only for the root directory in 5.19. In the 6.1 kernel, you'll see that extensions that I demoed earlier for extending that to subdirectories. So in the RC5 kernel, we have fallocate improvements from Dave Howells for insert and collapse range. If you don't build with SMB1, it's now 10 to 20% smaller. You have a new mount parameter close timeout to allow you to more sanely deal with deferred close. If you look at that example we saw earlier, you notice that after 5 seconds, the close came. That can be adjusted now if you're worried about server resource utilization, or you want to. There are cases, for example, where you have there are a significant number of cases that we have where you might just be copying thousands and thousands of files, and an hour later you want to go check if anything's changed. Sometimes this is an easier way by just making close timeout bigger. There's also been some locking improvements for multi-channel. Now, what is so important is when there's a bug, how do you fix it? Paolo and I were debugging a delayed unmount problem. Sounds easy, right? But it wasn't. So we have eBPF is the way forward for tracing. The kernel has changed radically in 4 years, the way you attack kernel problems because of eBPF, and Brendan Gregg and others have fantastic presentations. A couple years ago, Hani Namadi gave one on how to debug file problems and storage problems with eBPF. The problem was we didn't have trace points for what we were trying to debug yesterday. So feedback from you guys would help on events that are missing that you need for debugging customer problems, maybe server problems. We trace reconnect things, we trace open and close and various things, but there are places we're not allowing you to dynamically trace. What I love about eBPF is it has zero performance overhead, zero, until you need the trace point turned on. So this is unbelievably helpful, but we're in our infancy learning how to use it. eBPF, you go to the website, go see Brendan Gregg's talks. They force us as file system developers in Linux to listen to his talks for good reason. Yeah. Okay, ftrace, that's fair. Well, I talk about eBPF because Brendan Gregg likes to sell that concept, and he has his website and his books. But I agree. And I think, what was the talk 2 years ago? They called using storage, using superpowers. So they just described it as superpower. So, ftrace, eBPF, all of this is just the superpower you use in Linux to debug things. The problem is that there's all kinds of cool things that can be done that really have nothing to do with Berkeley packet filter. But I find it really interesting. I just wish I knew more about it, because there's lots of things we can learn. Okay, in the next few releases, you'll see improving directory releases. You'll see compression support. So we can negotiate it, but we don't do anything with it right now. And once the signing bugs are worked through, the GMAC 256 signing stuff, or sorry, the GMAC signing is done, we'll attack the compression support. Also, we need to be able to return additional fields. I gave a talk at the Linux File System Summit about how to return flags that Windows can advertise like offline, and be able to return those in StatX. Also, we have a problem in the VFS layer in Linux that FA notify, I notify is a local only call. Ironically, because even though it was invented by Samba, they broke it and made it local only 10 years ago. So we need to enable iNotify. We had some apps asking about that. Today there's an ioctl that you can call, a private ioctl you can call into to do notify, but it would be nice to be able to use the standard API for that. One of the things I really want to toss out there as important is quick. there's a kind of a process that we could talk about for doing quick. One way to do that is to use a stable user space library and upcall to it to make sure everything works from the SMB perspective, because the only users of quick right now that are super common are web browsers who don't care about the kernel, and SMB, which does. So one of the things we have to do is first upcall to a stable quick library, make sure everything's working, and then gradually move pieces of the quick driver into kernel. Once it's stable, then move it into the network directory. But right now, the users of quick is SMB. And so this staging is complicated, but quick has many advantages, not just security. And so I do encourage more discussion on that. We also need to continue to test the POSIX extensions to Samba server and ksmbd. We've been doing that a lot this week. And then there are plenty of performance improvements. Dave Howells just sent a set of things relating to folios and NetFS. There's a lot of caching improvements we can do. And we want to also test, we have wiki pages set up for each of the server targets as we go through test by test by test of the standard file system suite, trying to find any things that we can emulate, any things that need changes in the VFS layer, anything that need changes in our code, and finally, anything that needs new FSCTLs, new info levels, new Unix extensions for. We've added 15% more tests to the ksmbd group. We added about 25% more tests to the Azure target group. Remember, Azure has the smallest set of features because of the security concerns as a server. But we keep adding test after test as we go through slowly, test by test, trying to find, can we fix the VFS? Can we fix the CIFS driver? Can we emulate it? Or do we need a new feature? This is very important because the goal here is for the user not to know that they're running on an SMB mount. They really shouldn't have to know that they're running on ext4, XFS, SMB. Should just work. So this is very important. The reason they're called XFS tests, they don't have anything to do with XFS. They're the standard file system functional suite, and we've been going through that slowly. Anyway, CIFS-utils, new version of CIFS-utils. Our user space commands can do great things like checking snapshots and doing ACL manipulation and things like this. So it's fantastic to look at CIFS-utils. Contributions are encouraged. That's also easy to find out there on, in GitHub and samba.org. Okay, so we have time for any questions, I guess? Any questions from you guys? And by the way, before I forget, I want to thank a lot of people here who've been doing some great work on helping with this. The number of people who contribute to the kernel CIFS driver, large number of companies, large number of people, and it's very appreciated. Okay. Questions? If I don't have questions, I get to ask you guys questions.
I was curious for the build bot ran with the automated testing.
Yeah, so that's
very open to everybody.
Yeah. So here's a way to think about it. The build bot is. Let me see if I can even bring it up trivially. The build bot is. It's run in Azure. Oops, we're not connected to the internet here. I'll have to connect to the internet. Oh well. So it looks like I got to reconnect to the internet here. So the build bot runs in Azure, and it runs, they call it the build bot because there's standard Linux infrastructure for this. And what it does is it launches VMs from a web page that's hosted on a RHEL virtual machine in Azure, and it launches Windows VMs, it launches Samba VMs of various types. Some, for example, that use BTRFS and have the VFS BTRFS plugins to be able to do things like reflink, and then some standard Samba stuff. The kernel server we have a separate VM for, and then the Azure backends are just these storage servers in the same data center. So we have a set of targets, and then what we do on each individual test is, so we compile the kernel fairly strictly, so it finds leaks and things like that. And in this test run, we'll indicate in the test config what type of mount to do, whether we're mounting to Windows, we're mounting to Samba, we're mounting to Samba with BTRFS, we're mounting to ksmbd, we're mounting to Azure, whether we're mounting Azure multichannel. So we have the kind of which config we point to. We got about 30 different config, there's 30 different types of mounts, 30 or 40 different types of mounts we do. So we try to distribute the types of mount options we do across servers to cover as many cases as possible. And then we run an individual test and check maniacally for, were there reconnects during that test? That's a red flag. Were there error messages or warnings logged? That's a red flag. And of course, did the test succeed? And so we do this on every thing we send to Linux. Right now, we do have one regression we're dealing with, which is caused by delayed unmount. And we're trying to work through that. But this has been unbelievably helpful. The problem we have is it's a little bit slower than I'd like. And also that it's very tedious to go through 680 tests. And that's not counting other ones we run, like the Git functional tests. So we run a set of regression tests for other things, not just XFS tests. But 680 tests is a lot to go through. About 150 of them have no bearing on network file systems, but that still leaves over 500 tests to walk through, one by one by one. But we're trying to get to a mode like Samba, where testing is more important than development. You know, SMB Torture taught people a lot of lessons about how important testing is. So it's getting better. We got a lot of work to do, but it's getting better. And you know, many of these tests will probably eventually find regressions in servers too. You know, there have been some cases where we've seen red flags there too. So I think there is value in making sure testers for servers are aware of the client test stuff. And we have wiki pages that describe this. And so now, at least in Azure, for example, our testers do run these against Azure. And by the way, not just for SMB, but also for NFS, because these same tests run on any file system in Linux. Okay. What's your question?
There was a slide about the bucket packet filters that you had. Some slides. So I just wanted to know, like, how will we use part of SMB3?
For which?
The eBPF.
Oh, so eBPF is probably a misleading way to put it. So if you look at Brendan and Greg's website, or if you look at maybe the best thing to do is look at Hani Namadi's talk from 2 years ago. It goes through about 20 different examples, including ftrace, of how to do specific types of tracing in Linux when you have a storage problem. And there's a set of things that are possible. What I would focus on is the things that that depend on me, and that is adding dynamic trace points. So in Linux kernel client, we can add dynamic trace points that have names and can be enumerated that have zero performance impact until they're turned on. They take up zero code. So it's a kind of beautiful model in a way for me, because I can tell a customer, turn on trace-cmd and a specific event, and it's never hurt any other customer. All that it hurts is a slight performance degradation for him when he turns on that one trace point. Before, what we would end up doing is having 100,000 line logs that took weeks to go through. Now we can turn on individual events very easily by name. Now, the bigger infrastructure is much bigger than that. And I know maybe this much about it, but I do recommend you look at the talk on the SNIA talk from 2 years ago that Hani Namadi gave, which had a good overview, I thought. And then Brendan and Greg's website. And you might have you guys have other stuff you've seen? Yeah.
Just in case it's a question, this isn't a packet filter, right? It's not capturing SMB packets. There's a special stream of trace events in the kernel that you filter using the eBPF framework.
Yeah. So it started in the network.
It's included replacing
Yeah.
basically Brendan's.
Yeah. And what was interesting to me about this is that BPF started in the networking stack because they had networking events they wanted to be able to trace. So it has nothing to do with networking now. It just is the way you trace in Linux. You add these dynamic trace points. But along with that has been joint development with like Google, Amazon, Microsoft, and others have been working on extending eBPF tools and infrastructure in ways that are very confusing. There's actually summits that go on now for just this topic. At the File System Summit, they had a co-located event where the maintainers of these eBPF pieces would give their talks and argue about strategy and things. But it's an amazing amount of work, and it's overwhelming to me. What I care about, though, is the boring stuff, and that's how to debug this one problem that Paolo and I are dealing with. Like, how do we trace the exact events that are happening at unmount in this race without having a 100,000-line log to try to wade through? Okay, in the back?
How do you see the ksmbd evolving? So specifically, given that you have a user space server, Samba, which
Mm-hmm.
has all the functionality, I have last 30 years or so. Right?
Yep.
I see that you're also bridging the gap between that, right? Reusing some of the pieces specifically for DCRPs. You see that continuing, in other words, kernel ksmbd remains as a performance-centric stack, and you can kind of share the responsibilities with it. And even you see that going to a case where acts as a single server, maybe some shares which are like read-write bound, and that particular connection can be handed over to the kernel or SMB or something.
I mean,
It's a thought process.
so that's funny because it reminds me of 30 years ago. IBM had that with mainframes. They had a small front-end server that our team dealt with in IBM, and then you had a back-end mainframe server that other things were sent to. I don't think that's what we're talking about in the short term. In the long term, maybe, might be interesting. In the short term, let's look at it like a kernel developer. Kernel developers want small, easy-to-read code. You can't do that for DCRPC. So the kernel server may be useful for some workloads, but there's no sense at all in implementing low-performance operations like RPC calls in kernel. So there are plenty of RPC calls that are of interest. Maybe the witness protocol, I don't know, maybe, who knows? There may be other things. There are hundreds of different RPC calls, and some of them have to be handled in user space. Maybe all of them have to be handled in user space. And one of the goals was just in the long run to make it easier to tie these pieces together sanely so we don't end up duplicating a lot of work. And also so we keep the kernel server small, reviewable, and useful for its use cases. I think in the longer term, how they coexist and all that, there have been email discussions about that, but I don't have strong opinions about that. My short-term strong opinion is just making sure that the kernel server has the pieces that must be in kernel. And anything we can have Samba code do is better from my perspective, but that's personal opinion. But it's a good topic for the mailing list as well. Other thoughts? Okay, well, let's go get lunch.